Hello everyone and welcome to my channel Aptitude Club. Today in this video we are going to discuss this previous IIFT question from the topic escalators from time, speed and distance. Now as usual I'll request all of you to pause at this moment and try this question yourself first and then look at the explanation. Now this topic of escalators, this is quite interesting. We use the concept of effective speed. If I'll have to break down the time, speed, distance topic, so we can put it into three categories: relative speed and its applications, average speed and its applications, effective speed and its applications, and then some miscellaneous questions. Effective speed, under this we can have escalators and boat and stream both. Now effective speed means when the bodies are in touch. If the bodies are in touch, the speed of one will affect the speed of the other body. Like if I am moving on an escalator, if the escalator is going up and I am going up, then I'll go at a higher speed overall. I'll reach faster. But if I am going up but the escalator is coming down, so escalator is moving against my speed, so my speed will come down. Effective speed comes down. I move at the same speed, effectively my speed comes down because of opposite direction. That is how it works. Same principle in boat and stream also, but this question is specifically on escalator. And the interesting part is, if I say the total type of questions that you can expect in the escalator category, maybe this question would fall under the difficult side. Okay, it will be one of the toughest questions on escalators, but I'll help you with this with a technique called as HCF approach. Okay, we'll follow two approaches. One is HCF approach and one is LCM approach. So if you follow HCF approach, you can solve this question in 3 steps only. Okay, so you don't have to like solve a lot, you can just solve it in 3 steps. Now the bigger question is when to use HCF, when to use LCM, and how would you know? I'll give you one like simple clue. To read this question, an escalator is coming down at a constant speed. Hardik takes 40 steps to reach the bottom. Time in which he takes 15 steps, Kunal manages to reach the bottom by taking 45 steps. If the escalator were turned off, how many steps would they have to take to walk down? If you look at the question, there is no mention of time, isn't it? If you would have solved escalator question before, you'll see there will be some mention of time. These many seconds or these many hours or minutes or something of the other, or time would be mentioned. But here there is absolutely no mention of time. Hardik takes 40 steps to reach the bottom. Kunal takes 15 steps to reach the bottom. And the time in which Hardik takes 15, Kunal manages to take 45 steps, and so on. So everything is given only in steps. And that is when you use HCF approach. When there is no mention of time. When there is mention of time, use LCM approach. When time is mentioned. And using this, you can solve any question on escalators. Any question. So let us see what this HCF approach is all about. Now, there are basically three entities here. One is Hardik, one is Kunal, and one is the escalator. Okay, we have three things. We have Hardik, we have Kunal, and we have the escalator. Now, one clear relation between Hardik and Kunal is given, that the time in which Hardik takes 15 steps. So when Hardik is taking 15 steps, same time Kunal is taking 45 steps. So I can clearly say the speed ratio is 1:3. Hardik and Kunal speed ratio we know. So given a constant time, Hardik jitna steps, Kunal will be thrice that of Hardik. But this escalator, as of now, is an independent entity. We don't know the speed of the escalator. We can't even assume the speed of escalator as, let us say, these many steps per second. Because once you assume per second, you don't know the time. Time is not mentioned. So I'll assume the speed of the escalator in a way which will help us link it with Hardik and Kunal without mention of time. So the assumption here is the most crucial part. So what I'll do is, I'll take it in this way. Let the escalator takes e steps. I did not assume e steps per second. Whereas I'll assume it in this way. Let the escalator takes e steps for every 5 steps of Hardik. Now this 5 is the HCF. HCF of what? HCF of the numbers mentioned, 40, 15 and 45. So I got 5. So my assumption has to be done in this way. Let the escalator takes E steps for every 5 steps of Hardik. Now you might wonder what will happen if you assume in this way. Usual assumption should have been E steps per second because time is not known. Suppose time would have been given 10 seconds. So E steps per second, total number of steps taken is speed into time 10E. But because time is not given, so if you assume that way, it can still be solved, but it will get a little complicated. If you assume it in this way, it will be very easy. So let the escalator takes E steps for every 5 steps of Hardik. So total steps, if I count, how many steps did Hardik take to reach the bottom? Hardik takes 40 steps. So when Hardik takes 40 steps, how many steps will the escalator take? Hardik 5, escalator E. Hardik 1, escalator E by 5. Hardik 40, escalator E by 5 into 40. You get 8E. So the escalator will take 8 steps, 8E steps. Hardik takes 40 steps, and this is the total number of steps present. Let this be equation 1. And why did I add? Because the escalator is coming down, Hardik is also coming down. Both of them moving in the same direction, their distances you'll add. So 40 plus 80. So total steps to reach the bottom, Hardik taking 40, escalator simultaneously moving and taking 8E. I can also calculate the total steps from the point of view of Kunal. It is said that the time in which Hardik takes 15 steps, Kunal reaches the bottom by taking 45 steps. So Kunal is also moving on the escalator, and Kunal takes 45 steps to reach the bottom. Now we linked escalator with Hardik, but there can be an indirect link between Kunal and Hardik and escalator in this way. When Kunal takes 45 steps, Hardik takes 15, and when Hardik takes 15, how many steps will the escalator take? E by 5 into 15, I get 3E. So when Hardik takes 15 steps, escalator will take 3E steps. Or indirectly I can say when Kunal takes 45 steps, escalator will take 3E steps. So this is equation 2. And this is how things will get easier if you follow HCF approach. So I calculated the total number of steps. Always remember in escalator questions, total number of steps is the key. And we got it very easily using the HCF approach. So this number 5 is crucial. And I hope all of you understand why like we took 5 and how is it helping. Because it is easier to divide. That's the reason we took it as HCF and not any other number. You can take any other number, you will still get the same answer. I could have taken let escalator takes E steps for every 1 step of Hardik. The answer would have been proportionately the same thing. But if you take 5, it is more convenient. And this approach is called as HCF approach. Now because total number of steps is same in both the cases, so I can straight away equate 40 plus 8E is 45 plus 3E, or I get 5E is equal to 5. So E is equal to 1. What is the question asking? How many steps would they have to take to walk down? Question basically is asking the total number of steps. And total number of steps, you can use any one equation. Suppose I'll use 45 plus 3E. So 3 into 1, I get 48. You can use 40 plus 8E also. Either ways you'll get 48. So look at the solution. So simple. Just one assumption. You get two simple equations. Just equate them and you get done. Very easy. And difficult questions on escalators you can simplify and solve it super easy way by following the HCF approach. I hope all of you got an idea about this question. Previous IFT question this one is, and you can solve it in this method very easily. In another video I'll discuss the LCM approach, which is again easy. If you understand these two methods, any question on an escalator I guarantee you can solve very easily. Hope all of you understood this question and its explanation. If you have watched it this far, do subscribe to my Aptitude Club channel and explore the previous videos. You'll definitely find them useful on your CAT preparation journey. We'll meet again very soon in the next video. Till then, keep solving, keep studying. Thanks for watching. Bye-bye.